So, we are here today with Romeo Kienzler, Chief Data Scientist at IBM Watson, who was the first opening keynote of Data Natives 2018. Romeo, we had the pleasure to have you 2 years ago, and now you return. What has happened in these last 2 years? What can you share with our community?
So, a lot of things have been going on in the last 2 years. So, within IBM and outside IBM, so we saw some major breakthroughs in deep learning. So 2 years ago it was kind of starting and everybody was really skeptical about deep learning, and now we know that this will be the de facto standard for the AI transformation, and we learned a lot about new topologies of neural networks, so generative adversarial networks, for example, or that deep reinforcement learning is just getting hot now. And within IBM we have now a really clear open source strategy for deep learning. So in my talk I explained to you how important it is to have deep learning and AI at the hands of everybody, and not concentrated at a couple of multinationals, because then the models which are created and the data they are collecting is just biasing the market, and that's what IBM learned and also our clients learned.
And yes, it seems to be quite a recurring theme, I feel, with a lot of the talks that we had here with other speakers as well, and in the conference that we've been, unconscious bias, and also being able to have outcomes of using the data in an ethical manner, and not have disregarding some or based to others. It's a big topic, but at the same time, it's a very difficult topic, right? How can you ensure that, as you said, data is evenly distributed, is not in control of one corporation or one person, and B, that there's no bias? I mean, we as humans have, we have error, and we also make mistakes. So how can we also are the ones who have the false hypothesis? So how can we avoid this?
Okay, so many questions, also many answers. First of all, we are living in a biased world. So the biased world generates biased data.
Exactly.
And our models are trained on biased data. Okay. The first thing you should notice about deep learning is that we will never ever understand how they work internally. That's the nature of deep learning, because deep learning is nothing else than non-linear feature space transformations between the layers. So we actually don't understand what's happening in between. But we can assess the model from outside. So that's why we open sourced our bias detection toolkit. So we can monitor the model and we can detect bias. For example, if the model is racist or is against women. And in addition, we can mitigate. That means we can also adjust the model in a way that it reduces bias by retaining the accuracy. And regarding your question about data, so you won't be able to protect your data if you want to train it. So the only thing, in my opinion, what you can do is you just open it up. So for example, people think if I'm disclosing anonymous data to a large corporate, it shouldn't be a problem. But the real problem is that those corporates now can use your data to get really accurate, good deep learning, machine learning models. And in order to open that to the humanity, you should do open data. That means you can, if you publish your data anonymously, everybody can make use of the data, and that just equalizes this distribution.
Can you deep dive a little bit more on this topic? So how can you do that? How can you publish anonymously?
Okay, so one example I've also talked about in my keynote in the morning was the Mozilla project, which is called Common Voice. So it turns out that now the next wave of AI tools or gadgets is the personal assistants. Even IBM has one, but we have a B2B one. It's called Watson Personal Assistant, but the other corporates have also a B2C model, so Google Assistant, Alexa, and so on. The problem with that is that they are constantly recording. You have no control what they are doing. And the Common Voice project of Mozilla is trying to have an open source speech recognition algorithm. So Baidu published a paper which explains how their speech recognition algorithm works. That's also the reason why Google and the large corporates are publishing their algorithms, because without data you can not make use of them anyway. But now the Common Voice project of Mozilla is crowdsourcing labeled speech data. which you can use for training. And they have now implemented this algorithm, which was published by Baidu in TensorFlow, and it's called deep speech. And that for English already has the same accuracy as all the cloud providers have. And that means you can now have open source personal digital assistants which are running the speech recognition on the device. And since it's open source, you can actually ensure that it's already happening and not sent to the cloud. And actually, we are running a hackathon this weekend where we have an open source little robot, which is called TJBot. So it runs on a Raspberry Pi, the software is open source, and also the 3D printed case is open source. You can build it on your own. And in that hackathon, we will implement deep speech on the Raspberry for TJBot. So you have your personal digital assistant, which preserves your privacy.
But what exactly are you trying to figure out at the hackathon that you're doing? You mentioned this weekend?
Yeah, so the idea is that the implementation of this TJBot is open source, it's on GitHub, and we are there to mentor the students, and they will implement this open source speech recognizer on the Raspberry Pi and then contribute it back to the GitHub repository. So that means everybody can now start from there. It's like Edward Snowden said, you don't need to change the world. It's enough if everybody just builds a brick on others can build on top of that. And that's basically the idea. So we are supporting the students, they contribute to something, and after that the TJBot has a local speech recognizer, and on top of that everybody can build their stuff on top. So that's the idea.
Okay, so it's not a project that you want to figure something out of
No,
it.
the idea is to build a brick to improve, to go in the right direction. Yeah.
I see. Any other interesting projects? I mean, I know that when you were mentioning as well about building AI that humans need, you mentioned about the ethical toolkit that you have, the 360 toolkit in IBM. Can you tell us a little bit more about that? How, for example, does that work?
Okay, yeah, that was the one I mentioned before. That's the bias detection toolkit.
Yes, yeah.
It's called Fairness 360. So sorry for the name.
Okay.
That's IBM marketing. But actually it's a toolkit which you can use from Python. It's compatible to all the major deep learning frameworks like TensorFlow, Keras, PyTorch, and so on. And in Python code, you can assess the bias of your model. And in addition, you can choose from a set of algorithms which mitigate the bias. And that toolkit is meant to be part of any DevOps deployment pipeline. So before a model goes into production, always automatically this toolkit is executed. And that's also part of IBM OpenScale. That's the new product we are launching, which is actually about the management of deep learning models. And it supports a local installation. If you want to keep your model private at your data center, you can use the IBM Watson machine learning. But in addition, we also support all the major vendors like Microsoft, Google, and so on. So we have one single pipeline which can deploy the models anywhere. And in addition, it assesses the bias. And the next thing we are including in that's currently in beta, is the neural network synthesizer. So that's a neural network which is able to synthesize or create a new neural network. So the difficult task in coming up with a sophisticated neural network architecture is basically run by an AI.
I'm mind blown. There's so many projects, but you're not personally involved in all of them, are you?
Not really, no. So actually, I'm a bit stuck at one project. So when I started with IBM Watson IoT, I was really interested in deep learning, and nearly nobody was applying deep learning to sensor data time series. So deep learning was all about image recognition that time. So I found only 2 publications which have applied neural networks to time series. One was for stock market prediction and one was for vibration sensor data, and I took that one. I took the paper and I've re-implemented it in Keras, and I've open sourced that, and it's performing that well that now a couple of clients are running POCs with that, and now my task is to scale that. So apparently we have a lot of data. It's real-time data processing, because what this model does, it detects anomalies from production machines and it raises alerts, and that way we can prevent failures. And also we are involved in a project at the University Hospital of Zurich, where we are monitoring brain ICU data from patients, and the model can predict brain seizures in real time, 5 minutes in advance they occur, and that actually can save lives now.
Wow. Well, all very interesting projects, and I really want to see how they will evolve perhaps in the next couple of years as well. So with all of the things that you've been talking about, all the projects that you've been either indirectly or directly involved, I mean, coming the next 5 to 10 years, what is the future looking like for you? What do you see happening?
Okay. Yes, so at the moment we have one major problem when it comes to training of neural networks, that's gradient descent. Gradient descent is relatively hard to get right, it's computationally intensive. So I assume eventually we will come up with a better training algorithm. So the hottest topics are, for example, attention mechanism, where we actually tell the neural network where to look at. That's inspired by our brain. So we have an attention mechanism. So we have a flood of information coming in, but we pay attention only to a subset of the data, and that's the one we are training and learning on. That idea will be transferred to neural networks, definitely. And the second thing is deep reinforcement learning. So deep reinforcement learning needs a simulated space where it can act on. So there are actors in a simulation, and then what you do is you play against each other, or different versions of your network are playing against each other, and through genetic algorithms you just rebreed them and take the better one. The problem is that you need a simulator, so you can't apply it to the real world, and there is a risk but also an opportunity to run such models in the real world. So I just tell you a very dark side of it. So let's imagine that Boston Dynamics robots I've shown you in the keynote. So let's imagine you have 10,000 of those, and you go into war with them, and then you just learn them how to kill. That's one example. The other one, that's Terminator, yeah. The other one is, of course, self-driving cars. So we are quite good at self-driving cars, but still we are struggling in special situations, and eventually I think the society has to accept that self-driving cars will eventually kill people, because they are making errors like humans, but if the error rate is less than a human, the advantage is if a self-driving car creates an accident, all the self-driving cars will learn from it. If a human creates an accident, only the human is learning from it. So eventually we have to accept that also machines are allowed to make errors, which are severe, but that's...
Well, for the second example, I think it's even more dangerous to leave humans make mistakes, because as you say, if a human learns, then there's only a subjective and individual learning, whereas with the machines, perhaps that will be also like reinforcement learning. Afterwards, there will be no repetition in this kind of mistake. Yeah. But I guess like the problem with self-driving cars, at least my ethical consideration is more who they choose to kill, which is again a philosophical conversation, right? Because will they choose to kill, you know, if you have in between, like if you're driving a self-driving car and there's a bit a dilemma between killing one person or 5 people, who would you choose and what would be your parameters? There was a survey, I believe, that was conducted in the States about who they would prefer to be killed, and it was mainly older people and obese people, but is that fair? So again, sure, like someone, if there's a choice and you're either going to crush a car, you're going to crush a citizen, what would you choose? Then again, like I suppose like the question is like how big would be the scale of the error, and what kind of error would it be, and how many killings would it be?
If we are at a stage where we can make that decision, we are already very advanced. So at the moment, we will be happy if the car brakes at early enough to prevent an accident. So if the car already can predict and forecast the trajectory and choose who to kill, then I would suggest to use a random algorithm. So that's fair, no?
A random algorithm. Interesting. Yeah, perhaps that's fair. Yeah, because that's fate. Or at least that's how we call it. Anyway, any other final thoughts that you wanna share with us? I mean, you've been here 2 years ago. What do you think of the conference now?
Yeah, so it is growing, and now I think you have 5 floors, and the location I really like.
Awesome.
So I wish you good luck with your conference, and I'm sure you will grow fast.
Thank you.
Welcome.
We'll scale.
It depends how you define singularity. There are, I think, two ways of defining it. One is the super intelligence, and I think it's already starting. So how do you define super intelligence? But I think you can already say it's super intelligence if you outperform a human, and we outperformed humans 2015 already in the ImageNet classification problem, where a deep learning algorithm was at an error rate of 3.3%, where a human was around 6. So you can already consider this little part as super intelligence. And the other thing is consciousness. And in my opinion, an AI never ever will get consciousness. That's some more philosophical, religious thing. But it will be able to imitate consciousness based on our behavior and our data fingerprint.